Okay, we are gonna go with the topic called port security first. Port security. Okay, so you can write the heading port security. Okay, now consider this switch. This switch is connected to some computers like this. Okay, now here we got one interface and here we got another interface. We have connected it like this. Now let me tell you, here you got F0/1. In F0/1, one computer which is having suppose the IP is 10.0.0.1. 10.0.0.1, suppose it's /8, and here let us give the IP, say 10.0.0.2/8. Okay, now let me again tell you, so these computers will communicate with each other, and you guys know this computer has got a CAM table here, right? Sorry, not the computer, the switch has got a CAM table. You know about the CAM table, right? So the CAM table is also called MAC address table, and say you can view the MAC address table by executing a command. What is the command to view the CAM table? Show MAC space address-table. Now, so if this computer is trying to communicate to this one, say 10.0.0.2, when you are using the command ping 10.0.0.2, it's an incoming frame for the switch, right? If it's an incoming frame for the switch, the incoming frames shows MAC address. That means the PC0's MAC address will be there in the CAM table, or will be updated in the CAM table. Okay, so the CAM table or the MAC address table will be having then PC0 MAC sitting in F0/1, and say then when this machine replies, then PC1 MAC, it is there in F0/2. Clear? Now, so let me just show it to you here. Ping 10.0.0.2, you're getting the reply, and when you check this, show MAC space address-table, you can see two MAC addresses are there. In F0/1, PC0 is having the MAC address 1248, and F0/2, this PC is having the MAC address 6AAB. Okay, now the next thing, let me tell you what. So now consider that this is the organization's network, okay, and you got some internet connections, or say internet connections and all. Then consider, say we got Srikanth here. Okay, so Srikanth, say he is sitting here. He understood that they have got a very good internet connection, and the very next day what he's going to do is that he's going to come with his laptop. And he can connect a small connector here. He can have a small connector, a small handheld device, or he can have a small hub, again a small handheld hub, and he can connect from this switch to the connector, then he can connect it to his computer and then to his laptop. So he can have the access from this laptop to the internet, right? From his personal, say, laptop, he can use the internet and he can download the movies, or he can download anything, whatever he wants, he can download it. So he's misutilizing the company network. Yes or no? He's misutilizing the company network. So he should not do it, right? For that, we will configure something called port security. If you configure something called port security, the port security allows only one machine to be participated, or it only allows only one machine to participate in this interface, or in a single interface it allows only one machine to participate. Clear? So that means this laptop will not be allowed to communicate, because only PC0 will be allowed to communicate. So the concept is that when PC0 is sending something, then MAC address table will say fill that PC0 MAC address in F0/1. So that means already in F0/1, one machine is sitting. The port security, when this computer is trying to communicate, then port security understands there is already one person sitting, then they will not allow any more machines to be under F0/1. Clear? Got that concept?
Yeah.
Okay. So now let me show it to you. So now let me take a new laptop, or let me take a laptop. Okay, and let me just have a connector here. Okay, or let me just place a hub here. So there's the hub. Yes, and then we'll connect it. Yes. Okay, now again, suppose this computer is assigned with an IP, this laptop is assigned with an IP 10.003, suppose /8. Okay, now so suppose this is the legitimate device, they are communicating. Now this is the laptop, his personal laptop, Srikanth's personal laptop, and let's see whether he is able to communicate or not. He is also able to communicate. Why? Because port security has not been implemented here. We have not yet started the port, or we have not yet implemented the port security, so he is able to communicate. Now the next one. So now when you check show max space address -table, you can see there are two machines participating in F0/1. How many machines here? Two machines participating in F0/1. So the switch interface allows multiple MAC address to be under the same interface. Okay, so or the switch allows multiple MAC address to participate in the same interface, but when port security is configured, it allows only one machine. Okay, so now again, okay, later suppose that after some time it will get expired. Okay, it will get expired, and now let me configure the port security. Okay, to configure port security, we'll go to the interface of a switch. We'll go to that interface of a switch, interface fast Ethernet 0/1. We'll go to that interface of a switch, and we'll first mention or make it as access port. We'll first make it as access port. So the command is switch port mode access. Then we'll give the command switch port security. This is the command to enable port security. Switch port security. Okay. Then we'll execute the show command. Show max space address -table. So sorry, not max space. Say show port security is a command. Show command is show port -security. You can see fast Ethernet 0/1 is enabled with the port security, and maximum secure address is 1. Maximum secure address is 1, and current address is 0. So the current address, in the sense nobody has tried to communicate. Okay, and that's why it is 0. And you can see the security action. Security action is shut down. That means if at all this computer is trying to communicate, then there is one person already now in F0/1. Now if there is another machine sitting in F0/1 and he is trying to communicate, then that is the violation of port security. What does the port security says? It says only one machine is allowed in an interface. If you have any more machines in that interface, then the port security rule is violated. If the rule is violated, then the security action here will be shut down. The security action will be shut down in the sense you will be made, or you will make that interface down. Clear? So now let me just here, what we are going to do is, let me just ping from this device, the legitimate device. So ping 10.0.0.2. Okay, we are pinging to 10.0.0.2, or suppose we are utilizing the internet connection. So this machine is able to communicate. Okay, now from the laptop, if I try to communicate, let's see what happens. See here, you can see the interface is up now. Okay, from the laptop, if you try to communicate, the security action you are seeing it as shut down. So that means the interface will be made down. Shall we see it?
Yes.
So say 10.ping 10.0.0.2, you can say the interface, you can see that the interface went down. Why? Because there was already one person sitting and no other person can be permitted because the port security was implemented. Clear? Any doubt?
Now, can you remove PC1 please and try to ping from the laptop to the switch?
Sure. So, but
And also it works right. And
yeah,
also it works right because it allows any one machine, right? Be it a company laptop or a personal laptop in this case.
I'll come to that. Okay. So what happens is that, so I'll come to that, but just again in a moment. Now this interface has gone down. This interface has gone down. Now, if at all you want to make this interface up, you will go to that specific interface. In the sense that you will go.
So once the port security action has been taken by the switch,
The port security
after that we have
action,
to,
yeah, there's a shutdown
yeah,
action. Okay.
yeah.
Yes.
So we need to manually make it up, right?
Yes, you need to manually make it down first. So that's what I was telling. Say to make this interface up again. You make this interface up again. What you need to do is that you need to go to that interface. Interface fast internet 0/1. Okay, then you will make it down manually. You will make it down. Then you will make it up. You will give shutdown. Then you will give no shutdown. Okay, manually you made it down, then you made it up, then the interface will come up. Okay, now again the next thing. Now so somebody has raised a question. I'll come to your question, just give me some minutes. Okay, and after that I'll tell you what happens when you try to ping from this laptop. Okay, now so this interface has now gone down, right? Now again, what happens? Again, suppose this computer is trying to communicate. If this computer is trying to communicate, then it will be allowed to communicate. And later, when the laptop is trying to communicate, say again it will go down. So each and every time when the laptop is trying to communicate, the interface will go down. So that is a little bit difficult for us, right? So that means little bit difficult for the one who is sitting in the legitimate device. Okay, so that means say every time when the laptop is trying to communicate, it will go down. So at that time your work will get interrupted, right? So the person sitting here, suppose Srikanth or whoever it is, then their work will get say interrupt or it get affected, right? So the thing is that you again have some security actions or security modes, violation modes here. So by default it is shut down. The violation mode is shut down. Okay, say you got some more violation modes which are called restrict and protect. Protect and restrict. So protect here, when you make it as protect, the existing machine will be protected. The existing machine will be protected in the sense, say suppose I'm making it as protect. So to change the violation mode, again we'll go to that interface FA0/1 and we'll mention it like the switch port security violation. Okay, then I can show you three restrictions are there, or three violation modes are there: protect, restrict and shutdown. By default it is shutdown. Okay, now we'll have another value which is called protect. If it is protect, okay, if it is protect, let me tell you what happens. The existing machine will be protected. So that means if at all this computer is trying to communicate, he will be able to communicate. But what about the other machine? He will not be able to communicate. And also the thing is that this interface has not gone down. The interface has not made down. Clear? So that means the existing machine is protected. So that's why it's called protect. The existing machine can still communicate. Clear? Now you can see one more thing. You got one more command here. Do show port security or port -security interface fast internet 0/1. You can see the port security is enabled, the violation mode is protect, so and so forth. Now here the violation count is 0. The violation count in the sense, say how many times other computer has tried to violate it, it is 0. So in the protect mode, if you mention the protect mode, they will not keep track of this violation count. They will not keep track of this violation count. But in a restrict, I told you we got one more violation method or the violation mode, which is restrict. In restrict, what happens is that it is same as protect. It is protect only, but they will count the violation. They'll count the number of violations. So if you make it restrict, the existing machine will communicate. They are communicating. Now, what about the other machine? They will not communicate. Okay, they will not communicate. Moreover, again, you can see the violation count is 2 now, and later you can see the violation count is 3, and later you can see the violation count will become 4 as well here. Okay, because 4 times he tried to communicate, the other machine tried to communicate, so you can see how many violation counts are there. So that's the restrict. Clear? Any doubts? Okay, so this is the port security. Now,
So only difference is it shows the security violation count.
yes, it shows
Rest
it.
also.
Yes. Now, somebody asked a question here. Okay, now before that, let me just reload the switch. Okay, no, I don't want to save it. Okay, so now suppose that yes, somebody asked a question. Okay, previously, suppose. So this is the legitimate device. Now let me ask you a question here. How will the switch know that this is the legitimate device? Did I mention anything? No. Right. Then how will this switch identify this is the legitimate device? MAC address. But did we mention the MAC address? No. So the point here is that the port security, the concept with the port security is that, say, whoever tries to communicate first will be allowed. Okay, so that means here, say I was telling that this is the legitimate device. Yes, that is the legitimate device. How did I say, or how did that switch get that's a legitimate device? Because this machine tried to communicate first. So if this machine is trying to communicate first, then that machine, suppose PC0, this is PC0 and this is PC2, then PC0's MAC address will be stored in the CAM table. Okay, and that is considered as a legitimate device. Now,
it will store permanently. Store permanently. MAC address.
Yeah, that will store the MAC address permanently, in the sense in the CAM table that will be stored. Okay, now when PC2 is sending the frame, you got a person here. I mean, already you got a MAC address in F0/1, so that is why he is not allowing it. Clear? Now, what if PC2 is trying to communicate first, guys? What if PC2 is trying to communicate first? If PC2 is trying to communicate first, then suppose that you do not have any other, say, any other MAC address sitting in F0/1. At that case, PC2's MAC address will be placed in CAM table. Getting it? And PC0 will not be allowed to communicate. Let me show it to you. So let me just again, I have just reloaded the switch. Let me enable the port security. So interface fasten at 0/1 switch port security. Okay, yes, you need to first change it to say access, switch port mode access, then switch port security. Okay, and suppose switch port security violation, I am changing it to restrict itself. Okay, now suppose this machine is trying to communicate first. What happens, guys? What did I tell you? This machine will communicate. Yes or no? Okay, so you can see this machine is communicating. Okay, now if this computer is trying to communicate, he will not be allowed to communicate. So this is what happens in the port security. Okay, so I suppose whoever has asked the doubt, you're clear. Got it, guys?
What if we upgrade that
Upgrade that machine in the sense?
configuration, change the machine, whatever?
Yes, let me tell you. Okay, I'll come to your question also. Okay, now let me now tell you again. So what happens is that the machine which is trying to communicate first will be allowed to communicate. That should not happen, right? See, or the machines which are legitimate only, they should communicate. So we can mention this is the legitimate device. You can mention it like that also. So now let me tell you how you can mention it. Okay, so first let me clear the MAC address table. So when you check the MAC address table here, show MAC space address table, say in F0/1, one person is sitting. This is the laptop. 9C4 is the laptop. So let me clear it. Clear MAC space address table. Okay, now when you check, you do not have any MAC address. Okay, now what we are going to do is we are going to mention this is the legitimate machine. For that we will take the MAC address here. Okay, so ipconfig, in the computers you can get the MAC address by executing the command get MAC. Okay, but it will not work here, so I'm executing the command ipconfig /all. Okay, so here you can see this is the MAC address. 1248 is the MAC address. Okay, so let me copy it, and to mention that as the legitimate device, what I will do is that I'll go to that interface fastnet 0/1. I'll go to that interface and will mention mention the MAC address. Okay, so the command is switch port security MAC-address. This is the MAC address. Okay, so if I mention it like this, then that means I have mentioned to the switch that 1248, the machine with 1248 MAC address, this is the legitimate device. Clear? So even if this machine, the laptop, is trying to communicate first, he will not be allowed to communicate. Clear? Because we have mentioned this is the legitimate device and nobody else will be allowed to communicate. Shrikant? Okay, so now you can see, now when he is trying to communicate, he will not be able to communicate, because we already have mentioned that this machine 1248 machine is the legitimate device. And then what happens is that if you check do show MAC space address -table, then you can see this MAC address will be then placed in the CAM table. Any doubts? Now, what is the advantage of mentioning this MAC address manually? The advantage of mentioning the MAC address manually is that, say, do show run section 0/1. Okay, you can see this MAC address, it will automatically get automatically saved to the running configuration. Okay, when you mention these configurations, it will be there in the running configuration. And what is the advantage if you have these values in the running configuration? You can save these configurations as the startup config. You can save these configurations as the startup. So now let me save it. Okay, let me give the command do. So to save it, I might have told you the command is write. Okay, if you want to save the configurations from running config to the startup config, the command is write, or you will give do write, because you are in the inside interfaces. Okay, or the inside modes. So when you write it, then if you reload the switch, if at all the switch is reloaded, all the values will still remain, because we have saved these configurations. Okay, we have saved these configurations, and now when you check it, show MAC space address -table, you got 1248 in the MAC address table. Okay, so that means even if after the switch reloads, say even if this laptop is trying to communicate first, that will not be allowed to communicate, because we have saved the configuration and we still have 1248 in the CAM table. Clear? Any doubts? Now here, Nishant has asked it out. What if we need to change the machine? Suppose this computer has gone bad or this computer needs to be replaced. Then what do you do? Then you can mention, say, the no command here. You'll go to the config mode, you'll go to that specific interface fastnet 0/1, then you will mention do show run section 0/1. Okay, so you can just give no to this command, copy it, paste it, and you can just give no, and then later you can add whichever is the latest machine, you can add it. Clear? Got it? Okay. So now
In larger enterprises, I think this will not be used because there will be PCs keep on changing, right?
yes, okay. In the larger enterprises, let me again tell you, in the larger enterprises or in such cases, we will use something else. We will use what is called MAC address sticky configuration. MAC address sticky configuration. Okay, where you don't have to mention the MAC address manually. Okay, you don't have to mention the MAC address manually. The concept is that if you mention this sticky configuration, then automatically, so whichever computer is trying to communicate automatically, whichever is trying to communicate, they will automatically, these values will be added to the running config. Clear? Again, shall we take a look at it? Okay, suppose that I am negating this command. Okay, so let me give no here, copy and paste. Okay, now do show mac space address hyphen table. You do not have any values in the MAC address table. Okay, now let me enable, say, switch port security MAC hyphen address sticky. Okay, and do show run section 0/1. Okay, you can now you can't see any MAC address also here. In the running config, you do not have any MAC address. Now if this computer is trying to communicate, suppose this computer is trying to communicate,
You have to do it interface by interface.
not interface by interface, you can go to the range of interface and enable it. Okay, so now say suppose ping, this machine is trying to communicate, right? He is able to communicate. So now I haven't mentioned his MAC address. Now I've just given MAC address sticky. MAC address sticky. So what happens is that when you give MAC address sticky, then say whatever, say this is the frame that is incoming for the switch. So the incoming frame's MAC address will be stored in the CAM table. Of course, you know it. Along with that, that MAC address will be automatically placed in the running config. Will get automatically stick to the running config. We don't have to mention it manually. Clear? So now let me show it to you here. First, let me just show the MAC address table. Do show MAC space address hyphen table. You can see, yes, 1248 is there in F0/1. Now,
But it is static and dynamic.
yeah, that is static and dynamic. And dynamic means automatically he is receiving. And static here, when you mention or when you get it via the port security, then that is static. They consider it as static. Now, then do show run pipe section 0/1. You can see the MAC address, I didn't mention it manually, but it automatically got stick to the running configuration. So in the larger environments, we don't need to mention these MAC address manually, because in the larger environments, we'll have say hundreds of machines or 200s of machines and all. So in this sticky command will be used. So that means, yes, this will get, the MAC address will get automatically sticked to the running configuration. And the advantage is that you can save it by giving do write command, and even if the switch reloads, only these machines will be able to communicate. Clear? Okay. Any doubts? Okay.
Bharat,
Yes.
now also we have this BYOD, right? Bring your own device. So in that, like we have a different network. So we don't generally connect to the office network. We connect to the another network. So how? I mean, how they partition the network? Is it?
Yeah, it will be say something around, say, I really don't know the exact configuration they might be doing, but they can make them participate the X or the say the so-called, say the guest devices. Okay, or suppose if at all you have some other devices, your own devices, then that can be made to a separate VLAN there. Okay, that can be made to a separate VLAN, and what they will do is that, so for those VLAN they have the restrictions, they may have put the restrictions there. Okay, so for this VLAN to communicate to another VLAN, they'll have some restrictions. And also one more thing is there, say you will say, now that we are talking about the network things and all, right? So if at all you want to access the resources, then these guests will be, say, of course these are the networking things that we study. Then when we go to the server level, or when we go to the system level, again you will be having another server called domain controller. Okay, so if at all you have your own devices, then these are actually made into a group. Okay, they will be a part of the group, and the DC here, or the domain controller, from the domain controller you can set which all permissions need to be set, which all, say, groups you need to communicate, which all things you need to say have the things, or which all permissions they have. Everything can be set from the DC perspective. That is something else, that is from the server kind of thing. Okay, or from the system kind of thing. It is the application layer. But here we are now talking about the network layer and the data link layer. Okay, so what happens is that if you got any other machines, then they will be made to participate in different VLANs. Okay, and from that VLAN you will be having another, say, or you will be like granting the access, or you will be denying the access, or whatever it is, you will be doing that. Got it?
Yes, thank you.
Okay. Now, so this is the case. Now, one more thing. What if you have the requirement to make both the computers work in this interface? If both the computers need to work in this interface, you can set, so by default I told you MAC port security allows only one MAC address in an interface by default. Okay, so if at all you want these two machines to communicate in this interface, you can change it. You can change it to the number of machines. You can make it to 2, 3, 4, 5, whatever is your requirement. You can make that much number of machines. Okay, so what we will do is that we will go to the switch, we will go to that interface, then we will mention the command switch port security maximum, then we'll give 2, 3 or 4, whatever is your requirement, you will give it. Maximum MAC address in an interface can be up to 132. Okay, so here you can see 132 machines can be made to participate in that interface. Okay, so say if I make it 2, then 2 computers will be able to communicate. So that means here, say this machine, say the desktop is able to communicate, and also the laptop is also able to communicate. And the third machine, if you have a third machine, they will not be able to communicate. Clear? Any doubts in this one? Port security. So this is it. It's done now. Clear? So these. So this is the port security. Okay. Now we'll go with another concept called Etherchannel.
We have
3 more printer.
PVST and MST.
Yeah, I'll come. Okay, I'll know. Okay, so Etherchannel. After the Etherchannel, I'll teach you that. Okay, no worries. So Etherchannel. Okay. So now Etherchannel, let me tell you about it. Suppose you got a switch here. Okay, and you got another switch here. Now suppose you got some connections, or this is the connection F0/, okay, just give me a moment, guys. So guys, if at all I get logged off, just wait for me. I don't know, I have kept it for charging, but yeah. Might be okay. Yes, it's fine now. So now, yes. Now guys, now let me tell you. So suppose you have a connection. F0/1 is connected to F0/1 here. Okay. And you got many computers here. You got multiple computers here. And here also you got multiple computers. Now these computers are trying to communicate, and if at all they are trying to communicate, say they just connected using a fast Ethernet, and the fast Ethernet has got a bandwidth of 100 megabits per second. What if the data that all the computers are sending and everything together, they are receiving 200 megabits per second? You only have 100 megabits per second here. The bandwidth is only 100 megabits per second, but sorry guys. So now, you are receiving the data at the rate of 200 megabits per second. In that case, you will have congestion. Okay, so congestion will be there, and so to avoid congestion, what you can do? Yes, of course, one method is to increase the bandwidth. Say one method is to say, suppose this interface supports only 100 Mbps. So if at all your switch is having a gigabit Ethernet interface, you can connect to a gigabit Ethernet interface. You can remove this and connect it to gigabit. Okay, but what if the switch does not have the gigabit? Store the values. But
Bundle.
again, yes.
Bundle 2 or more links.
Yeah, of course you can do that. Okay, I am coming to that. So now, storing the value, that is not really possible, because every second they are receiving 100 Mbps, extra 100 Mbps. Okay, so it will get accumulated like that. Again, say congestion.
Go to market and purchase it. Go to market and purchase it.
Go to market and purchase. Okay. So now let me just tell you. So here you can connect multiple interfaces. Am I right? Okay. You can connect, say F0/2 you can connect, F0/3 also you can connect. Okay. But the problem is that, say if you connect F0/2 to F0/2 and F0/3 to F0/4, or whichever interface it is, 3 or 4 or 5, whatever, whichever interface it is. The problem is that, say, the span tree will block these unnecessary ports. I've taught you, if you got multiple paths to reach from one switch to another switch, the span tree will block the unnecessary ports. So what happens is that even if you connect multiple interfaces, you will not have any, say, effect there. Then what you will do is that, suppose, say, let me just show it to you how the spanning tree is blocking. Okay, so this is switch 1 and switch 2. Now we'll connect, say, F0/2 and 2, and again 3 and 3 as well. Okay, and then later, say, let me okay, so now you can see, say, switch 2, all the interfaces are, yes, up, but here 2 interfaces are down, or say they have made it down, the spanning tree has made it down, because here there are chances that the loop will occur, so the spanning tree will consider the individual interfaces, they'll get blocked. Okay, now let me tell you here. So in this case, what we are going to do is that we need redundancy. That means we need multiple paths. At the same time, the spanning tree should not block it. For that, we will configure something called Etherchannel. We'll configure something called Etherchannel. So let me tell you about Etherchannel. Etherchannel will tell switch, hey switch 1, okay, consider, so now we got how many interfaces connected? F0/1, 0/2 and 0/3. Similarly, you got 0/1, 0/2 and 0/3. Now we'll tell the switch, hey switch, do not consider these as the individual interfaces. Bundle them together. and consider it as a single interface. Consider it as a single interface. So the switch 1 will now consider, so this switch 1, okay, switch 1 will now consider all these interfaces as a single interface now, and that interface is called port channel. What is it called? Port channel. So it can be port channel number 1. The same we'll mention it in switch 2 also. We'll go to switch 2, we'll mention it like this. Hey switch 2, do not consider these as the individual interface, but bundle them together and consider it as a single interface, which is called port channel. Okay, it can be port channel 2, port channel 3, whichever interface you want, you can have it. Okay, so you got the interface is called port channel. So when the spanning tree is running, the spanning tree will not consider the individual interfaces, they will consider the port channels only. Okay, so they will come to know, or the spanning tree when they check it, say they will consider the port channel only, and these interfaces will not get blocked. At the same time, you will get, say, the bandwidth also. So here 300 Mbps you will get, here also you will get 300 Mbps bandwidth. Clear? Any doubt? So this is what we are gonna do. Okay, we are gonna create the ether channel, we are gonna create the port channel. So to create that, what I'm gonna do is that, say, I'll go to these switches. So first, let me give the host names. Suppose the host name is S1. Okay, and for this switch, let me give the host name S2. Host name is S2. Okay, then so now again let me show it to you. In switch 1, when you take it, now that we have not done the ether channel, when you take it, show spanning -tree, you can see F0/1, it is, yes, it is in the forwarding, but F0/2 and 3, it is in the block state. It's in the block state. So that's why, say, you can see the spanning tree is blocking these guys. Okay, now that we are going to implement the ether channel, so ether channel, to implement it, what we are going to do is we'll go to that range of interfaces. We'll first go into that range of interface. Okay, now again, so we'll interface range fastnet 0/1-3. We will then make these interfaces shut down. Okay, we'll make all these interfaces first down. Okay, the same thing we'll do it in switch 2 as well. We'll go to the interfaces here, the range of interface. Interface range fastnet 0/1-3, and we'll make those interfaces as down, admin down. Okay, now to do the ether channel, you can do it using 2 ways. The first is called manual configuration. We will make the ether channel manually, or we will configure the ether channel manually. Okay, so that is called on mode. That's called on mode. We are manually making this ether channel on. Okay, or we are manually configuring the ether channel, so it's called on mode. Clear? Okay, now the second is by using the protocols. The second is by using the protocols. So using the protocols, say you got 2 protocols here. The first protocol is called LACP, Link Aggregation Control Protocol. Link Aggregation Control Protocol, LACP. That's, we'll study LACP also. Now the second is called PAGP. PAGP is Port Aggregation Protocol. Port Aggregation Protocol. So PAGP is not there for you, but LACP is there for you. So we will configure it manually, and we will configure it via LACP also.
Which is the best practice, manually or via protocol?
Via protocol will be the, say, good one, because if you go with, say, LACP, then if it's required, then that will automatically form the ether channel. Okay, if it's not required, then they will not form it. Okay, or else if it's manual, then we'll have to make it manually, right? We'll have to configure them manually. Now let me now go with,
Sir, LACP is open standard, right?
Yes, LACP, it is developed by IEEE. Okay, LACP is developed by IEEE, whereas PAGP is Cisco proprietary. Okay, so LACP, yes, IEEE one. Now, so first we will configure it manually. So to configure it manually, again we'll go to that range. We are already in the range of interfaces, where you will mention, then you will mention the command like this: channel hyphen group, channel hyphen group, then the group number. The group number means, I told you, so what we are going to do is, we'll have the switch 1, we'll have the switch 2, and now we will create, or we will bundle it in a port channel. And the port channel, say this interface should have a number, right? Port channel 1, 2, 3, 4, any number. So this number is the group number. This number is the group number. Okay, so here we'll give the group number here, channel hyphen group, then the group number, it can be 1 or 2 or 3, like that. Okay,
So can I give a question mark here?
yes, of course you can give the question mark. Then you can have the numbers from 1 to 6.
Maximum 6 group.
Yes, maximum 6 here. Okay, then you can suppose I'm giving 1, then I can give mode on. I told you we are manually making it on, so the mode is on. Okay, done. Then you can see creating a port channel interface. That means the port channel is actually a virtual interface. Okay, if you ask me, sir, show me the port channel, a physical port channel, I can't show you because that's a virtual concept, and all the interfaces are bundled together, and then that port channel is formed. Clear? Now again, so when you check do show IP interface brief, you can see one port channel has been created. One, here you can see a new interface port channel has been created, but it is down bar down because we have manually made it down now. Okay, so this is the command. What you will give is that channel hyphen group mode on. Okay, now we'll go to the next switch. We are already in the range of interfaces where we'll be giving the command channel hyphen group. Then you can give group number 1, 2, 3 or 4, 5 or 6, any number you can give. Yes, if you want you can give 2 also or 1 also. Then you will give mode on. Done. So creating the port channel interface 2. Okay, then what you're going to do is you will manually make these up. You will manually make these interfaces up. So to make it up, you will give the command no shut. Yes. Now you need to make it no shutdown together in both the switches. Okay, so now we'll make this up here. Again we'll make it up here. Okay, together we'll make it up, and then you can see after some time it will come up. And can you see any interface in down state or any block state? No, because the spanning tree will consider it as the, say, not as the individual interfaces but as the, yes, the port, the port channel. Okay, the bundled ether channel. So here when you take a look at it, say do show span or do show spanning hyphen tree. So previously you have seen the interfaces, right? F0/1 was up where the others was blocked. So here we can see only a single interface, which is port channel 1. Clear? So now the spanning tree is not considering the individual interfaces, they are considering it together as a single interface, which is the port channel 1. Okay, now you got some more commands here. Say the command is show ether channel. Show ether channel. So you can see show ether channel group number 1. That means the number is 1, the port channel 1, and the group state is L2. L2 means it is working as L2 interface. Okay, then the ports, you have 3 ports here. How many ports you have? 3 ports. And maximum, say you can bundle 8 ports in this, say, port channel. Okay, now port channel is 1, maximum port channel is also now 1, and you do not have any protocol now. The protocol is nil. Okay, now you got one more command, show ether channel summary, in which you can see in the port channel 1 how many interfaces are there? 3 interfaces are there. Which are those 3 interfaces? F0/1, F0/2 and F0/3 here. Clear? So this is how you will do the ether channel configuration. Any doubt? Clear?
Sir,
Yes.
suppose we have bundled 3 ports in the switch one, in between switch and switch, right?
Hmm.
So if anyone, by mistake or, intentionally remove one cable from that bundle,
Hmm.
in that case, port channel will be up or down? Total.
In that case, the port channel will remain up. But this interface, suppose if you remove F0/3, then that will go down. Let me show it to you. So let me,
Ether channel will walk.
ether channel will work.
Okay.
Okay. So here, if I remove this, okay, I really don't know which interface I removed. Okay, but let us see. Okay. So now, yeah, 0/3 itself. Okay. Now when you check show ether channel summary, you can see the ether channel is still up. Okay, so if the port channel 1 SU here means, S means say it is layer 2 and U means it is in use. Okay, so it is still working, and then you can see F0/1 and 2 are working, but the F0/3 has gone. D means down here. Okay, where is it? D. Yes, so down. Clear? Okay, so whichever is the interface which are removed, that will go down. Got it? But the ether channel will still be working. Clear? Okay. Now, one more thing. If at all you want to make this port channel as up, what will you do? You will go to that, say port channel not as up, it has a trunk, suppose. So the port channel interface will now work as a normal switch interface. You can give it as access, you can give it as trunk, you can give it as say you can configure it as .1Q trunk, you can configure it as say ISL trunk, you can change the native VLAN, like that you can do anything and everything. It will act as a normal switch interface. Getting it? So to do the configurations in the port channel, you don't have to go to the range of interface now, you can go to that interface port channel itself. So interface port channel 1. Okay, then you can give switch port mode trunk, or switch port mode access, or switch port mode dynamic, whatever you want you can give it. Clear? So this is how you will give you will do the configurations in the port channel also. Got it? Okay. Now shall we now so now that we have done is manual configuration of ether channel. Now shall we go with the protocol? Okay, so I told you can configure the ether channel using manual method, and the second was using protocol. So now yes, LACP. So you will study LACP. So again, let me take 2 more switches here. 2 more switches. So suppose this S3 and S4. Okay, so now let me connect it. F0/1 to 1, 2 to 2, and 3 to 3. Okay, if you check that, you will see it's 1 to 1, 2 to 2, and 3 to 3. Okay. Yes. So what we will do is that so again, let me change the host names here first. Host name S3, okay, and here host name S4. Okay, now that what we are going to do, we'll go to the range of interface range fast internet 0/1-3 will manually shut it. Okay, and again the same thing here also, interface range fast internet 0/1-3, then shut it. Okay, then now we are going to do using the protocol. So here we will mention channel-protocol, then which protocol we are using? LACP protocol we are using. So we will mention like this, channel-protocol LACP. Then we will mention channel-group, say the group number, suppose it is 1, then mode. So previously we are given the mode on, now we got some other modes as well. Okay, so this time the modes are something else. Okay, yes, the modes are, say for LACP you got some other modes which are called active mode and passive mode. We got a mode called active mode and passive mode. Now if you are using PAGP, then the PAGP, say you got similar modes here for PAGP. It is called desirable and auto. Desirable and auto. Now that we are not gonna say, I'm not gonna teach you about PAGP, just understand it. Okay, so the similar modes you have it in PAGP as well. Now for LACP you got active and passive modes. Okay, so now active mode. So here what happens is that you can make one, say interface or one end as active mode, and the other end it can be an active mode also. Okay, then they will form this LACP, or they will form ether channel. They can form ether channel. Then one end can be active and the other end can be passive also. Then also they'll form ether channel. Now one end, if it is passive, then the other end cannot be passive, or it should not be passive. If both are passive, then they will not form ether channel. Getting it? Okay, so make sure that you have at least one active interface, or the one side with the active interface or the active mode here. Getting it? And active means what happens is that when you configure active, they will send certain messages to the other end. Say guys, hello other end, shall we form the LACP or shall we form the ether channel or not? That's what they will send, and those messages are called negotiation message. Negotiation messages. They'll send the negotiation message, and the passive will only accept the negotiation message. They will not send it. They'll only accept the negotiation message. Clear? So now let me go to this switch 3 and mention active.
But in other ways, can we tell like this passive mode will passively waits for the active initiations, right?
Yes, of course you can say. It will wait for, say, the active negotiation. You can say it like that. The passive is, say, that will wait. Say that will keep on waiting till it receives some negotiation message. Okay, exactly. So here you can say I'm gonna give active here. Okay, then at the other end, suppose the same thing. First we'll mention channel hyphen protocol. Then we'll mention the protocol as LACP. Then we'll mention channel hyphen group. You can give any group number. Suppose I'm giving group number 2. Then more. Suppose I can give passive. Okay. Then what I'm gonna do is I'll give no shutdown. Okay. I'll give no shutdown here. Together we'll give no shut. Okay. And later it will form ether channel. Okay. So here when you check it, show ether channel summary. Here you can see port channel 1 consists of, or the protocol is LACP. It consists of 3 interfaces, F0/1, 2 and 3. Any doubts? So this is the port channel configuration or the ether channel configuration. Okay. Yes. Now I'll come to your portion. Okay. So now shall we take a small break and then continue? Yeah. Okay. So
sir, one small question.
Yes.
Etherchannel can be built between the same kind of link, right?
Same kind of
Link.
Yeah, of course. Say they have some, say when you do the ether channel concept, they have some conditions here. Say when you have this, say here it is faster than it. So here if it is gigabit, or say then if it is different type, or if it is different, then there are chances that the issues will happen. They will not form the ether channel. So for ether channel the conditions are there. Say the conditions, one condition says they need to have the same bandwidth. They need to have the same bandwidth. So even the gigabit Ethernet interface can work with the fast internet, but the interface here must be working with 100 Mbps. Okay, so the bandwidth here needs to be same. The duplex, say the duplex settings need to be same. So and so conditions are there. Only if the conditions satisfy, then say they will work, or else they will throw some errors. Got it?
Okay, sir.
Okay. So now we'll take a small break, and after the break we'll continue with, say, the topic PVST, MST, CST. Okay, theoretically. Okay, yes. So guys, we'll come back at 9:20. Okay, yes. Yes, guys. So, shall we start again? Okay. Now, yes. Now we'll come to this one. So, PVST, MST, and CST. So, now, let me tell you about CST. CST is common spanning tree. Common spanning tree. Common spanning tree. Now, common spanning tree. Common spanning tree. So in common spanning tree, let me tell you, say suppose, let me take a topology here. You got S1, you got S2, and you got S3. So again, let me make it bigger. S2 and S3. Suppose you have some interfaces like this. Okay, now if you have, say, the topology like this, then, and you got some VLANs also. Consider you got some VLANs. So all the switches has got some VLANs here. VLAN 10, VLAN 20, VLAN 30, VLAN 40, 50, 60, 70, 80, 90, 100, and VLAN 1 also by default. Okay. Now for all these VLANs, say just this is just an example here, guys. Okay. Suppose if we have this much VLANs, even if we have this much VLANs, the common spanning tree runs the spanning tree for all the VLANs. So, or let me tell you, here suppose S1 is having the priority 0, S2 is having the priority 4096, S3 is having the priority 8192. Who will become the root switch? S1 will become the root switch. For all the VLANs, S1 will become the root switch. Okay, for everyone, or we will be running a single spanning tree instance here in the common spanning tree. That means for all the VLANs here, the root switch will be this S1. The priority is say 0 and the root switch is S1. So in that case, say what happens is that this will become the designated, these two will become the designated. Consider these two are the root port, and consider this as the designated and this as the blocked. So sorry, for all the VLANs we will be running a single spanning tree instance. Clear? So if you consider VLAN 1, this is the root switch. For VLAN 10, this is the root switch. For VLAN 20, this is the root switch. For VLAN 30, 40, 50, 60, every one, this is the root switch, and this is how it is working. Clear? Okay. It's as if, say, let me tell you a non-technical example. It's as if, say, suppose you are studying in class 10. Consider you are studying in class 10. In class 10, I am selecting a leader. I am selecting a leader. For all the, say, for physics, chemistry, biology, maths, for all the subjects, I am, say, considering a single leader. So the leader selection process will be taken, or say the election will be taken, or the election will be conducted. For everyone, or for all the periods, or for all the, say, what do you say, not the language, what is it, subjects, I'll be selecting a single leader. The same thing here, for all the VLANs, we'll be selecting a single root switch, and for all the VLANs, we'll be selecting, or we'll be running a single spanning tree instance. Clear? Fine. Now, PVST. That's it. Okay. So nothing else. Say only the theory. How say this is it. Okay. So the PVST here, per VLAN spanning tree. Per VLAN spanning tree, PVST. Okay. It can be considered like this. Suppose you got, say, in class 10, I suppose 6 subjects are there, right? Say science. When I studied, there were 6 subjects. Science, social science, then what was it? Maths, English, yes, Sanskrit or second language or whatever. Okay, Sanskrit. Now, only 5 or whatever. Okay. Now for each period we are selecting a leader. For science, for each subject we are selecting. For science, we are selecting Kevin as the leader. For social science, we are selecting Srikanth as the leader. For maths, we are selecting Nishant as the leader. For English also, suppose I am selecting Nishant as the leader. That's my choice. For each subject, we are selecting each leader. Okay, or it is similar to that. Let me tell you the exact thing here. Suppose you got the topology like this, S1, S2 and S3. Okay, and say suppose we got multiple VLANs here. VLAN 1, VLAN 10, VLAN 20, VLAN 30, etc. Okay, so what happens is that for each VLAN, suppose for VLAN 1, for VLAN 10, for VLAN 20, VLAN 30. Okay. For each VLAN, suppose for VLAN 1. For VLAN 1, you can customize it accordingly. For VLAN 1, say you will run separate, say spanning tree instance. You can configure everything separately. So for VLAN 1, say this can be made as the root switch. The priority can be 0 here, this priority can be 4096, and this priority can be 8192. Okay, for VLAN 10, you can configure this as the root switch, S2 as the root switch. So the priority is 0, here it is 4096, and here it can be 8192 for VLAN 10. And for VLAN 20, this can be the root switch, 0. Okay, and this can be 8192, and this can be 4096. And for VLAN 30, this can be the root switch, so the priority is 0. Okay, for S1, this can be say 32768 can be the priority. For S3, say 61440 can be the priority. So for each VLAN, you can customize it accordingly, and you can give your own value so that you can say have, or you are running separate spanning tree instance for each VLAN, and that is why it's called per VLAN spanning tree. For each VLAN, you are running separate instance. We use it. The Cisco switches, they will go with PVST. That's why, say you can see, say I have mentioned the command like this. I might have mentioned when I configured it like this. Say spanning -tree VLAN 1 priority 0. That's how we configured it at that time, if you remember, right? So again, or spanning -tree VLAN 10 priority 0. You can give it like that, no issues. Okay, so for each VLAN you will run separate spanning tree. Yeah, here. So the advantage of using this PVST, you can have load balancing. Let me tell you. So here, common spanning tree. Common spanning tree for all the VLANs. This is the link. Okay, so all the VLAN traffic will be passing through this link only, right? If some machines are communicating from this machine, some we are communicating to this machine, I mean switch 2, machines in switch 2, then all the VLANs here will use this link. If it's VLAN 1, VLAN 10, VLAN 20, VLAN 30, 40, 50, 60, 70, 80, 90, 100, everyone will start using this interface. Now, this is not at all used by anyone, so that is simply wasted, right? It is not at all used by anyone. But here you can see for VLAN 1 here, VLAN 1, say suppose these are the designated, okay, and suppose these are the root, and this is the designated, and this is the blocked. Now for VLAN 10, say suppose these are the designated, and these are the root, and this is the designated, and this is the block. Consider. Okay, then you can see VLAN 1 traffic will not pass through this link. Okay, but VLAN 10 traffic will pass through this link. Right? Getting it? So now, say if at all VLAN 1 is blocked here, VLAN 10 is not blocked. VLAN 10 is passing the frame. So you'll have load balancing kind of things. Okay, so that means if at all, say the VLAN 1s are sending it the packets or sending the frames, it has to be sent like this. Whereas VLAN, say 10 will be sending it like this. Now VLAN 20 might be sending, say suppose VLAN 20 here, this is the blocked. So they might be utilizing these two links. So there you got load balancing thing. Getting it? Okay. And you can customize it on your own. That is also another thing. You You can customize it on your own.
So we have to configure it manually.
Yes, you have to configure that manually. Okay, so for each VLAN you got their own spanning tree instance. If you have 10 VLAN, then 10 spanning tree instance will be run. And it has also got some other problems also. What is the problem? If you got 10 VLANs, you have to run 10 instances. Right. If you got 100 VLANs, they will run 100 instances. 100 VLANs will not be there, but if in case, say you will have to run 100 separate instances. Now, then
If it is a single switch with multiple VLANs, then this is required.
if it's a single switch, then whether we require the STP here?
No.
Okay, it's a single switch. Okay, in case of multiple switch, so again, say STP is required. Okay, what if, yes, let me tell you, what if this machine is connected, this is connected to a computer. Okay, and from this computer, you got, say the computers, you can install multiple NICs. Okay, and this is connected, say, to some switch or another interface here. Okay, so in order to avoid the loops and all, you will have the spanning tree running. Okay, and again, let me tell you, say, but here the spanning tree they will run, but again what happens is that, say they got, say one NIC will be having one MAC address and another NIC will be having another MAC address. Those things and separate different things are there. I'm not going into those part now. Now, so here we are not really concerned about that, but switch to switch will be running spanning tree. Okay, so at that instant the spanning tree is concerned, or the spanning tree is important. Got it. Now we'll come to next thing called MST, multiple spanning tree. Multiple spanning tree. Multiple spanning tree is again a customization. Suppose you got VLAN 1, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay. You can group some VLANs together. VLAN 10, 20, 30. Or VLAN 1, 10, 20, 30. Then 40, 50, 60, 70, 80. Then 90, 100. So this can be one single instance. It can be called as, say, MST instance 0 or MST instance 1 or something. And this can be one instance, MST instance 1. This can be another instance, MST instance 2. Then for MST instance 1, you can configure, suppose this is MST instance 0. Okay, and this is MST instance 1. And this is MST instance 2. This MST 2, this MST 1. So for MST 0, you can configure this as the root switch. This is the 0 priority. This is 4096. This is 8192. And this is, say, suppose S2 here. This can be the, for MST instance 1, this can be the root switch. This can be, say, with the priority is 4096. This can be 8192. For this can be the root switch. Say 0, 8192, 4096. So you can have in a single, say, in a single instance of MST, you can have multiple VLANs. Clear? So here customization means here, even if you have 10 VLANs, you don't need to run 10 instances. If you run 10 parallel instances, again the resources will be utilized. Here not that much utilization will be there because we are running only 3 instances. Right? The spanning tree only we are running 3 instances here. Clear? Yes.
There is some command for this.
Of course. Okay. We don't have the configuration thing, that will be covered in NP level. Okay. Yes. Even I forgot that. Okay. Now, so this is the PVST, MST and CST. What happened? Fine. Okay. Now, any doubts in this topic? Okay. Then, so the switching is complete now. The switching is complete. Okay. Now we got some small things. Okay, not small things, some are big topics. So did I show you this one? Okay, let me pause recording now. Okay, so guys, VTP, regarding VTP, let me just show it to you. As you asked, let me show it to you. So let me ask you a question. Why VTP is used?
To create VLANs automatically.
Yes. Okay, to create the VLANs automatically. So then I told you, you need to have, or there should be certain conditions. Certain conditions should satisfy. What are the conditions? Yesterday I told you that also.
Same VTP domain,
Yes.
same
Domain?
trunk line,
Yes. The trunk link, it should be connected between the trunk link and
password should be same.
if at all
VTP
the
password.
VTP, you can, it's not mandatory to configure the password, but if at all the VTP password is configured, it should be same. Okay, so let me now show it to you. Suppose, say, FA0/1 is connected to 1 here. Okay, so now just let me configure. It's simple thing, don't have that much things and all. So now what I'm gonna do is I'm gonna first configure the trunk link here. Okay, so interface FA0/1 switch port mode trunk. I've configured it as trunk. Okay, now when you take a look at here, it will also be a trunk. Okay, you know that I've already shown it to you. Now I'm gonna configure the VTP password, the VTP domain. So the VTP domain, it can be configured like this. Say, suppose Cisco. Okay, then suppose that I create a VLAN 10 here, VLAN 20 here, VLAN 30 here, VLAN 40 here, VLAN 50 here. Fine. So when you take, so this is the switch 1 here, or switch 5. Host name is switch 5. Host name is switch 5. Okay, in switch 5 we have created VLANs 10, 20, 30, 40 and 50. Okay, this is switch 6. Host name is switch 6. We haven't configured anything in switch 6 yet. Now if you take a look at the switches here, do show VLAN. I mean, take a look at the S5 switch. Okay, you can see, say VLAN 10, 20, 30, 40, 50 are there. Okay, now if you take a look at, so we haven't configured any VLANs in switch 6, but still if you take a look at the switch 6, do show VLAN, it ought to show here. You can see it has automatically created the VLANs in switch 6. We didn't do anything. Okay, now suppose again I'm creating another sub VLANs here in S5. In switch 5 again I'm connecting, or I'm creating some VLANs. VLAN 100, say 101, I don't think it will work. Okay, so VLAN 100, VLAN 101, VLAN 102, VLAN 103, VLAN 104, VLAN 105. Okay, so previously in switch 6 we didn't have any 101, 102 and all, right? So when you check it now, you can see again in here also they have created VLAN 100, 101, 102, 103, 104, 105. So this is the VTP in a nutshell. Got it, Vijesh?
Yeah. So in server mode, client mode, and transparent mode, right?
Yes,
So that also can we see here, or?
of course. Do show VTP status. Okay, you can see by default it is working in server mode. Where is it? Yes, VTP feature. So VTP operating mode is VTP server. By default it is VTP server. If at all you want to change it to client, then you can configure it like this: VTP mode client. If you configure it as client, then again do show VTP status. You can see now it has changed to client. Now client, you can't configure any VLANs in the client. So now if you configure VLAN 200, VLAN 200, it's just saying VTP VLAN configuration not allowed when the device is in client mode. Okay, now if at all you want to change it to transparent, you can change the VTP mode to transparent. Okay, then if you check it, it is now transparent. Got it?
Yeah. Thank you.
So this is the VTP configs. Anything else? Okay. Now that we got some more topics here, Portfast, and are you sure that I didn't teach you Portfast and BPDuguard? Okay. No worries. So I'll teach you. So Portfast. So now, suppose I'm taking the computer. Okay. I'm connecting the computer to an interface of the switch. How much time it will take? Yes. Okay, it's not minutes, it's seconds. So it'll take 30 seconds. The usual is 30 seconds. Okay, it'll take 30 seconds. So let me show it to you. Do so span. You can see. So it's in learning state. F0/2 is in learning state. Okay. So of course you can see multiple. Say yes. You can see many things here. Okay, because we have implemented many VLANs and they will be running, say yes, PVST. Okay, per VLAN spanning tree, and you can see VLAN, for each VLAN they are running the spanning tree instance. For VLAN 105 they are running the spanning tree instance. For 104 they are running the spanning tree instance. For 103 they are running the spanning tree instance. Like that they are running the spanning tree instance for everyone. Okay, but we only require VLAN 1 now. Okay. So here you can see, say F0/2, first it was in the listening state, then it was in the learning state, then it will be in the forwarding state. Okay, again if at all I disconnect it, and if at all again I reconnect, it will take 30 seconds for the interface to come up. It's not up yet. It will again take 30 seconds. Okay, now to make this come up faster, that too to the interfaces connected to the end device. To the interfaces connected to the end device, we really don't want to run the STP. There's no meaning in running the STP if it's connected to the end device, because we know that end device is connected. We will not have any loop here. Okay, so we are really not concerned, or we are really not interested in running the STP or the spanning tree here in those interfaces connected to the end device. Then you can
Even it is a server also, right?
Sorry?
Even it is a server also.
Even if it's a server also. Okay. So here we can directly make that interface to become in the forwarding state by skipping the listening state and the learning state. Okay, so what you will do is that if you implement the Portfast, port will get up faster. Okay, so it will say you have listening state and learning state which will be skipped, and they will come to a forwarding state directly. Clear? So now how to implement Portfast? You will go to that specific interface. Interface, I suppose it is F0/2. Yes. Interface FA0/2, and you're gonna say switch port. Sorry, the command is spanning-tree. Spanning-tree Portfast. This is the command. Spanning-tree Portfast. If you implement this one, then you can read this. And there is a warning there. Portfast should only be enabled to the ports connected to a single host. Connecting hub, concentrators, switches, bridges, etc. to this interface when Portfast is enabled can cause temporary bridging loops. Portfast have been configured on FA0/2, but will be having its effect when the interface is in a non-trunking mode. So you have to make sure that you have not connected any, say, switches, bridges, etc. to this interface, and the only device connected to this interface is the end device or the edge device. Clear? Okay, now if you disconnect and if you connect it back, it has become up immediately, right? It has become up immediately, and again do so span VLAN 1. You can see it has come up immediately. Clear? It didn't go to listening state or learning state or anything. It just came up immediately because we have just bypassed, or we have just skipped the listening and the learning state. Clear? Okay. Then the next one.
This will be done on a port level or switch level, because if it's a port level, then we have to do it for all ports, right?
can be done in switch level as well. To do it in switch level, again I forgot that command, let me just say can be done in switch level also, because again as you told, you need to go and do it in all the interfaces like that. So you can go to the config mode and enable the Portfast like this.
Sir, can we take the range command?
Yeah, of course you can go to range and also execute this as well, no issues. Okay, so either you can go to the range level and execute this, or you can go to the config mode and mention like this spanning-tree Portfast default or something. Okay, then whichever is the access mode, say they will become the, or it will be enabled with the Portfast. Okay.
And sir, one other important thing, I think we need to give this command on the access layer switch only, right?
Yes, access layer switch, because in the access layer switches are the switches which
Only
is
this
connected to
end device are connected.
yes. Okay, so now after implementing this command, do show run say section 0 / something. Okay, nope, it didn't get implemented. Okay, only got implemented in switch, I mean in F0/2. Okay, maybe some other command, or maybe like say spanning-tree Portfast default. Yeah, default is a command to enable the Portfast by default on all the access port. Okay, on all the access port, yes. Okay, so again interface range, if at all you go to FA0/1-24 switch port mode access. Okay, then do show run pipe section 0 / you can see access, it has become access, but still it has the port security, I mean the Portfast has not come. Maybe in the real switches it will come. Okay, I suppose that it is maybe the packet tracer and it's not working in the packet tracer. Okay, so the command here, yes, that leave that one. So the command here is that you will go to the config mode and you will mention it like this spanning-tree Portfast default. Okay, to make the to do it in the switch level. Okay, now the next thing, BPDuguard. Okay, so BPDuguard, now let me tell you, that also is executed to the interfaces connected to the end devices. That also is executed to the interfaces connected to the end devices. Let me tell you. So here, if you got an end device here, so the end device is a computer, and now the computer will not send BPDU. So BPDU is sent by the switches. So now suppose somebody disconnects this interface and connects it to a switch here. Then the switch will send the BPDUs. Then if you configure the BPDuguard, then this BPDuguard will guard this interface from receiving the BPDU. How will it guard it? If at all this interface is receiving the BPDU, this interface will be made down. The interface will be made down, or it will be made to go it in air disabled state. It will be made to go in air disabled state. Shall we check? Okay, now if you connect switch, there will be no issues, because we haven't done any BPDuguard now. Okay, if you connect the switches, we will not have any issue because we do not have configured any BPDuguard. Okay, but if you configure a BPDuguard here, suppose in F0/2 I am going to configure BPDuguard. So interface FA0/2 will mention the command like the switch port. Sorry, the command is spanning-tree. Okay, spanning-tree BPDuguard enable is the command. Spanning-tree BPDuguard enable. Now you will not have any issue because no switch is connected. But if at all a switch is connected, then you can see the interface will go down. The interface will come up and it will go down now, and you can read it. So interface has changed to up, then receiving the BPDU or received BPDU on port F0/2 with BPDuguard enabled, disabling the port.
Why we need it?
Why?
We need it.
Why we need it means, say nobody should be connecting a switch to the interfaces which is connected to the computer. Okay, so these are the access modes, right? These are the access mode interfaces, and it should be got connected to the computers or the end devices. Nobody else should be connecting a switch here. So if at all somebody connects a switch, say, there are chances that unauthorized switch can become the root switch. Okay.
Yeah, the topology got changed.
Sorry?
The topology might have changed.
Yes, the topology will get changed. So they will get aligned with respect to the root switch, and the topology also may change.
For security purpose.
Yes, for security purpose, we'll configure the BPDuguard. So,
Full form?
BPDuguard. What is BPDU? What is BPDU? What is the full form of BPDU? Yes, guys. Full form. of
Bridge that
Bridge. You missed something. Bridge Protocol Data Unit. Okay. Bridge Protocol Data Unit. Yes. So here you can see received BPDU on port so and so port. BPDuguard error detected on 0/2. So the say putting 0/2 in error disabled state. So if at all this is in error disabled state, you can see it. Say the command to see whether it's in error disabled status, show interface status. Show interface status. Here you can see, yes, F0/2 has now gone to error disabled state. So if at all it's an error disabled state, first what you need to do is that first you need to disconnect it. Disconnect whatever is unnecessary device, you can disconnect it, and you can connect it back to the say the correct device, but still it will be down. So to make it work again, you will have to go to that interface fastnet 0/2, shut down manually, shut it down manually, and then you can make it up, no shut. Yeah. So this is how.
if the spanning tree priority for the third switch, right, the switch which we are connecting new, say here switch 7 is set to maximum, that is 61,440, then that will not become the root switch, right?
Will not become the root switch.
Then even if BPDuguard is not there, it's not an issue, right?
Can't say it like that.
Yes, in the topology, sir, can I tell you one important point?
Yeah, of course. Yes.
If the switch is very old, then it might have a bigger impact on your topology, switching topology.
Yeah. So that, let me tell you, if the switch is older, say if at all, the thing is that if the switch is old, then they will have the lower MAC address. Okay, so that's why the priority is set. Say suppose the priority is 0 here and the priority is 4096 here, then he was asking, even if this is a say older switch also, say of course there will be no chances that some issues will happen, but still there are chances. There are chances means, say what if the VTP is configured. If VTP is configured, again what happens is that, say there will be certain situations where the VLAN will get deleted. You have many things there. Okay, so if you connect a switch here, and if at all the switch is, say if at all the switch sends certain VTP messages, the VLANs, whatever VLANs we have will get deleted and all. So we really do not want any switch to connect here. Okay, so that is also one more thing here. And another thing is that, say if you connect a switch here, and the switch will receive the BPDU and you can capture it. Okay, so this switch will not be configured to send the BPDU, but still what happens is that, say there are certain attacks. Okay, so to avoid that attack, we will do the BPDuguard, and to avoid this from becoming the root switch, you have another configuration called BPDU filter. You got BPDU filter? No, not the BPDU filter, guys. Say that is root guard. You got another config called root guard. Guard the root. That's it. So you still got many things there. In spanning tree, when you go to the CCNP level, you got some more things there. Got it? Okay.
And another thing is, sir, whenever we add any switches in the existing switching topology, we always make that switch first in a transparent mode, so that
Yes,
all
of
the
course.
debiting numbers got zero.
Yes.
Set to zero.
Yes.
Then only we add the switch, because we don't know what is the configuration in there. Instead of checking the configuration, if I suddenly add the switch in the existing topology, entire topology may be collapsed and the enterprise switching topology will go down.
Exactly. Okay. So again, there are so many things there, guys. Okay, VTP, SAs, STP, so many things are there. Okay, and I don't think VTP they have mentioned it like this. Okay, they might have say when I check the textbook they have mentioned only small thing there. Okay, so that's it. I mean, any other doubts, Vijesh,
No, I'm good. Thank you.
Srikanta?
PAGP is not no more. I think there, right, sir?
Yeah. PAGP, even the Cisco is not even telling about PAGP. Even Cisco is telling us to go with say LACP, it supports 16 link and all. PAGP, it supports only 8 links and all. And again, you got many things there, but PAGP they have not mentioned it. Okay, but still, I taught you. You should know. I like simply I taught you.
It is not there in CCNP also, right, sir?
That I'm not sure. Okay. For CCNP, it might be there, I think. I'm not sure about it. When you go to CCNP, CCNP faculty will tell you about that. Okay. Yes. Okay. Anything else? Yeah. Nishant, Kevin, Srikant, Ratik, where were you yesterday? God. Okay.
I forgot to set a test.
Sadish. Okay. Okay, guys. Then shall we wind up?
Homework.
Hmm?
Homework.
Sorry.
Homework.
Homework. Okay. Did I tell you that I'll give homework? Okay. No worries. I'll give homework. So, with respect to which topic? Spanning tree. Yeah, spanning tree. I can give you homework. Say maybe to find out I really don't remember. Maybe to find out the root port, the root switch, like that. Okay. Then I'll give you another homework. Say paint. S1. S2. S3. S4. S5. Let me draw it, guys. Then any of you can take the screenshot or snapshot and share it in the group. Okay. Or okay, let it be like this one. Okay. Now like this. Suppose this is gig 0, this is gig 1, and this is gig 0, gig 1, gig 2. Now this is gig 0, gig 1, this is gig 2, suppose this is F0/1, F0/2, F0/3, F0/4, and this is gig 0, gig 1.
I used to have gig 2.
Where, in which one?
S2.
S2 gig, S2 only gig 0, gig 1 and gig 2 only, right? So
Where we have it.
where you will?
Gig 2.
Gig 2 is connected from S2 to S4. Okay. So this is the diagram, and I'll give you the priority also. 0 is the priority, 4096 is the priority, 8192 is the priority here. Again 4096 is the priority here. Or suppose instead of 4096, let me again give, say, let this be 4096, okay, and let this be 8192, and let this be 32768, and let this be 61440. Okay. Okay, yes. So if you are done, you can leave for today, guys. We'll come back tomorrow.